All right, happy snow day, everybody. I'm going to finish up section 2.3. We really only have two more examples in this section, and then you can move on to section 4.6. All right, so I want you to look at your 2.3 notes and back up a little bit. These are examples that we did in class on Friday, so I just kind of want to remind you of what we were doing. All right, so we did this example with limit laws. We justified each step that we could distribute limits over addition and subtraction. Took forever, a bunch of paper, and in the end, we found out that really all we were doing was plugging in 2. Okay, so you should have this in your notes. We got the number 7 as our answer. And we said, well, can't we just do that? Can't we just plug in x equals 2 to do the limit? And I said, yes, as long as you get an answer, a number, polynomial, rational function, then this is all you have to do to evaluate the limit. All right. But then we ran into this problem where we were substituting in and we would get 0 over 0. And I said 0 over 0 always means a removable discontinuity. It means a trick. Okay, so this means that we need a trick. And in this one, we did this in class. Our trick was to factor and cancel. All right, and we found an x minus 3 factor on top that would cancel with the one on the bottom. That was what was causing the 0 over 0, and we were able to find the limit. All right, and then the next one we did was this one. This one, again, when we plugged in, we got 0 over 0, all right, which means 0 over 0 always means you need a trick. And this one, we just needed a little bit of algebra. Okay, so we FOILed this thing out. And eventually we were able to factor out an h that canceled with this h that was on the bottom. And that was our trick, just to do a little bit of algebra. And simplify. All right, so we got 2 more tricks I want to show you. And the first one is how to deal with a complex fraction. All right, so this one is also going to give us 0 over 0. So let's go ahead and just do that because we always want to try to plug in first. So you've got a complex fraction, a little fraction within a fraction. So I'm going to plug in x equals negative 3 and just see what happens. Because if it's a number, then I'm done and I don't have to do anything special. All right, so I plug in negative 3 plus 2 in that little fraction, plus 1. On the bottom, negative 3 plus 3. All right, we can already see that 0 down there at the bottom, so that's not looking good. And up top, this thing right here, that's just 1 over negative 1. All right, so we end up with negative 1 plus 1 on top, which is our 0 over 0. So again, we're going to need a trick. Okay, and we need to simplify this complex fraction, and there's lots of good ways to do this. I'm just going to show you one of them because I think it's the fastest way. All right, so our trick is going to be to get rid of this little fraction up at the front. And you do that by multiplying through by that denominator, that x plus 2. So I'm going to multiply on top by x plus 2 and on bottom. So this is kind of what you do when you're finding common denominators, is exactly what you do in algebra to find common denominator. This is really a clever version of the number 1. So I'm just multiplying this limit by the number 1. I'm not really changing it. All right, but I got to be careful to put parentheses here. So up top, I'm going to distribute this here to see what falls out. On the bottom, I'm just going to leave these 2 factors the way they are. Okay, so recopy the limit. Limit x goes to negative 3. On the bottom, I'm just going to leave these factors because we can see that factor, that x plus 3, that's what's causing your 0 on the bottom. So I'm hoping that's going to cancel out with something on the top. So I'm not going to FOIL that out. I'm just going to leave it that way. But the top, I am going to distribute that x plus 2. So I'm going to get that itty bitty fraction up here. It's going to get an x plus 2. And then I'm distributing to this 1 here. I give that one an x plus 2. All right. And I'm going to think of this x plus 2 here as being x plus 2 over 1. Okay, because then those 2 factors can cancel out. Okay, so this whole big term here has canceled out to be 1. And that was the point of using that x plus 2 on the top, so that it would cancel out that complex fraction, that fraction within a fraction. So that's going to be 1. And then over here, if you want to think about distributing that 1, or just 1 times anything is equal to the anything, this is just going to be x plus 2. Okay, so what I have left, I still haven't taken the limit. I keep copying my limit as x goes to -3. I've got 1 in the first place, and then I've got x plus 2 in the second place. And then I'm recopying this denominator. It's just going along for the ride for the moment. Okay. Now, because of this addition up here, you can't cancel those x plus 2's, and I don't really want to cancel x plus 2's anyway. I'm really interested in getting rid of that x plus 3 because that's what's giving me trouble. All right. But this whole numerator, if I just simplify it, the 1 and the 2 make a 3. So up top now, I've got x plus 3, and on bottom, x plus 3, x plus 2. All right. And then now you see the x plus 3 on top and bottom. Like I said, with some algebra, that 0 over 0 always reveals itself at some point. So those can divide out. And then I'm just left with a 1 on top and an x plus 2 on bottom. All right, and then I can plug in. Once you've canceled out that 0 over 0, you can try to plug in again. I'm going to plug in -3. Okay, so that's 1 over -1, and that limit is equal to 1. All right, so that was our trick. This trick was to simplify a complex fraction. Ooh, this stylus gives me great handwriting. I don't know if you guys have noticed that. All right, so that's our third trick. So we've got factor and cancel. We've got a little bit of algebra. This one, simplifying a complex fraction. And like I said, there are other ways to handle this one. So if you had a different idea and you still get down to -1, that's okay. You can do it a different way. But I think this one's probably the fastest way. All right, so our last trick is what to do when you have these radicals. Okay, so again, always with a limit, plug in and see if something falls out. If you just get a number, then you don't need a trick. All right, so we always try to plug in first. So I'm going to plug in x equals 4 for this limit. I'm going to get square root 5 minus 4. And we see this going south quickly. All right, so I've got square root of 5 minus 4. That's 1. 4 minus 4 is 0, and we get our infamous 0 over 0. Okay, and 0 over 0 always means a trick. Okay, so our trick is going to be to rationalize whatever has the radical. So you may have learned how to rationalize fractions with radicals in them in high school. Even if you did, you probably didn't see anything that was this complicated. All right, so the way you rationalize, the thing that has the root up here, you're going to multiply this by the same exact thing, but we're going to change that sign. It's a negative right now. I'm going to change it to a plus. Okay, so I'm going to multiply this by root, exactly the same thing, 5 minus x, but I'm going to make that a plus 1. Now, if I multiply that on top, I have to multiply that on bottom as well. Okay. All right, so by changing the sign in the middle, you're creating a difference of squares. It's going to get rid of the square root on top. It's going to put it down on the bottom, but that's going to be okay. So on the bottom, we're just going to leave these things in parentheses. We really want that x minus 4 to cancel out with something, so I don't want to go foiling it and getting it all mixed up with something else. But up top, I'm hoping I can get an x minus 4 to show up to cancel with the thing on the bottom. Okay, so this is a really complicated FOIL on top. All right, so on the bottom, so let's copy our limit. The bottom of my limit is going to just stay like this. It looks like a mess, but it's just going to hang out and go along for the ride. Up top, I'm going to be doing a FOIL. Okay, so I do my first, my outer, and then I'll come through and do my inner and my last. Okay, so when I multiply my first two terms, those two square roots, those are both square root 5 minus x times 5 minus x. Okay, and you can see that's going to make that square root disappear in a minute. Okay, so that's my first terms. Now I'm going to do my outer terms. Okay, so that square root times 1. Okay, so that was FO, first, outer, inner, Now I'm going to do my inner terms. That's the -1 and the 5x. Okay, so that's going to give me minus root 5 minus x. And then my last term, -1 times +1, which is a -1. Okay, so you can see what's happened here, right? We have these two terms are the same thing. One's positive, one negative, so they cancel out. That gets rid of that radical. And here I have a square root and a square. Those are going to also cancel out. So a lot of stuff falls out by multiplying by this term up top. When you do this with a radical and you just change the term and change the sign in the middle, this is called multiplying by the conjugate. You don't have to know that, but if you'd like to have a word to throw around at parties, there you go. Okay, so we're multiplying by the conjugate. It makes this radical stuff fall out in the middle. Okay, so let's see what we have left. Okay, so I've got limit as x goes to 4. Up top, my radicals disappeared, so that first term is just 5 minus x. The radicals in the middle disappeared, and I've got a -1. And then I've got on bottom x minus 4 and this radical here. All right, and at first glance, this may look a little bit disappointing because on top, okay, if I simplify up here, the 5 minus 1, I get a 4 minus x. Or actually, let's write that as -x plus 4. And then on bottom, I've got x minus 4. Okay, so like so close, but not quite, right? These almost cancel out, those x minus 4s. But you can see when I plug in when I plug in x equals 4 here, -4 plus 4, I'm also getting the 0. So that's my 0, but it doesn't exactly cancel out with on the bottom. All right, but it will if I factor out a -1. Right? That leaves me with an x minus 4. All right, so if I do that, then that x minus 4 will cancel out. Okay, so that all just leaves me with a -1 on top. All right, so then I'm almost ready to do my limit. I've gotten rid of my 0 over 0. I've got limit as x goes to 4. The -1 on top. And then this weird radical business from my conjugate on bottom. Okay, and now when I plug in 4, I'm not going to have anything equal to 0. -1 on top is just -1. Square root 5 minus 4 plus 1. And I get -1 over, that's the radical, that's just 1. Radical 1. 1 plus 1. I get -1/2. Okay. All right, so this time the trick was to use the conjugate to rationalize. Okay, so section 2.3, by and large, finding limits, you're just plugging in or you're using a trick. We had factor and cancel, do some algebra, simplify a complex fraction, or rationalize. Okay, so that's it for section 2.3. You should be able to finish up that homework now, and I will also have a video or 7. I don't know how many it's going to take me to get through section 4.6. Won't take me 7. All right.